Bismillahirrahmanirrahim. How are you, students? Today we will study subject physics class first year, and topic is collision. Now, now collision is today topic. Collision is a collision is the event in which two or more bodies exert forces on each other in about a relative short time. This is called head-on collision. This is called head-on collision. Head-on collision. When one body hit the other body, when one body hit the other body, physical contact. When a body comes in physical contact. Collision occurs when one object strikes another. Problems involving collision are usually solved using conservation of momentum and conservation of energy. Collision occurs when one object strikes another. There are two types of collision: inelastic collision and elastic collision. Proton, positive charge particle, and the other positive charge particle. It will not come in physical contact. When this proton is brought in motion in this direction, it will bend in this direction, or it will bend in this direction. It will not hit the object directly. It will not come in physical contact with this proton because of electrostatic force of repulsion. So after this, collision is defined as when one body, when one body, when two interacting body come closer so that they affect the velocity of each other. So they affect the velocity of each other. So when two bodies affect the velocity, interact with each other and affect the velocity of each other is called collision. So for collision, physical contact is not necessary. The collision of two balls is head-on collision. So in elastic collision, momentum is conserved. Kinetic energy is not conserved. Is not conserved. Elastic collision, momentum is conserved and kinetic energy is conserved. So inelastic collision is what? We define an inelastic collision as a collision in which momentum is conserved but kinetic energy is not. The collision of a rubber ball with a hard surface is inelastic. And an elastic collision is defined as one in which both momentum and kinetic energy are conserved. Billiard ball collision and the collision of air molecules with the walls of a container at ordinary temperature are highly elastic. The collision of subatomic particles are also elastic. So we will go into detail of elastic collision in which momentum is conserved, kinetic energy is conserved. So we will apply law of conservation of momentum and law of conservation of energy. Both are applicable. Both are applicable. So we will study a little detail, then we will go into further detail. In elastic collision, some of the kinetic energy is converted into another form. For example, this is inelastic collision. If one body hit the other body, sound is produced, heat is produced, so energy loss. There is energy loss. So in this type of collision, energy loss, there will be energy loss, and in elastic collision, no energy loss. In fully inelastic collision, the maximum possible kinetic energy is lost and the object sticks together. However, in many inelastic collision, this is not the case. only kinetic energy is lost in inelastic collision. Kinetic in inelastic collision, inelastic collision. Kinetic energy before collision is equal to kinetic energy after collision plus energy converted into other form of energy, sound and heat. We can define this along with the conservation of momentum, which is always conserved to work out the motion of objects after collision, before collision. This is velocity of this particle. This is the velocity of this particle. This is the mass of this particle. This is the mass of this particle. After collision, velocity changes. Velocity changes. Mass remains constant. Mass remains constant. Sound and heat. Energy loss is in the shape of sound and heat. So before collision, the energy of this will be equal to the energy of this plus heat energy and sound plus the energy produced during heat and sound. So there is energy loss. This is inelastic collision. So energy is lost in this example. Now elastic collision. In elastic collision, all of the energy remains as kinetic energy. No energy is lost to other forms. This means that both kinetic energy and momentum are conserved. Momentum, kinetic energy before collision is equal to kinetic energy of both the bodies after collision. Momentum before collision is equal to momentum after collision. So if this is the velocity, we will change this representation. We will take it V1. This is V2. This is V1 prime. This is V2 prime. Okay. This is mass M1. This is mass M2. M1, M2. Mass remains constant. Momentum of this particle is M1 V1. Mass into velocity. Momentum of this particle is P2 into V2. P1 prime. M1 P1 prime. P2 is equal to M2 V2 prime. This is P2 prime. After collision. So after collision, momentum is P1 prime of first particle. And momentum of second particle is P2 prime. P1 is before collision and P2 is before collision. This is not. This is momentum before collision. This is momentum before collision. This is momentum after collision. Momentum after collision. These will be equal. These will be equal. This is the statement of law of conservation of momentum. So can be written M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime. M1 V1 M2 V2. M1 V1 prime plus M2 V2 prime. Okay. Now this is example, typical example. Molecules. Total momentum before collision is this one. We have written V1, we have written V1, V2. So this is V1 prime, V2 prime. This is M2. This is P1 plus P2. This is P1 prime plus P2 prime. These will be equal. These will be equal. This is equal to this. 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 This is the statement of law of conservation of momentum. Total momentum before collision, after collision. VA means V1. Here V1, V2, V1, V2. According to law of conservation of energy, total kinetic energy before collision and total kinetic energy after collision. This, and this. So write this is V1. This is V2. This is 1. This is 2. This is VA means A is used for 1, B is used for 2. Okay? Here, now, here we will write M1 V1 in place of this. This will be transferred to this side, and we will write in place of that M1 V1 prime is equal to MB. In place of this, I will write M1 V2, M2 V2 prime. This will be transferred to this side, so it will become negative M2 V2. Okay, so simplifying this equation, taking M1 common, V1 minus V1 prime is equal to M2 is equal to V2 minus V2. This equation you will memorize. I will erase, I will work on the second equation. Okay. Now, after simplification of this equation, this 2 will be cancelled. In place of this, I will write M1 V1 square. This will be transferred to this side, and I will write in place of MA V1, and in place of this, I will write V1 prime square is equal to M2 V2 square prime. This is shifted to the other side, it will become minus M2 V2 square, this one. When M1 is taken common, we will write M1 V1 square minus V1 prime square is equal to M2 V2 prime square minus V2 square. So this equation is further simplified. We will write M1 is equal to V1 minus V1 prime V1 plus V2 is equal to M2 V2 prime minus V2 prime plus V2. By applying the formula, A square plus B square is equal to A square minus B square. A square minus B square is equal to A minus B into A plus B. So we have obtained two equations. One is this one. M1 V1 minus V1 prime, V1 plus V1 prime. And the second one is M2 V2 prime minus V2 plus V2. Dividing this equation by the equation which is obtained from this M1 V1 minus V1 prime into V2 prime minus V2. So this will be cancelled. So simply we will obtain V1 plus V1 prime is equal to V2 plus V2 prime. Now we will revise it. Elastic collision. Initial kinetic energy of this body and this body. Collision. After collision, kinetic energy final. Now discuss. If the total kinetic energy is conserved, Kinetic energy total initial is equal to total final. Means this plus this. This is initial of one body. This is the initial of the other body. This kinetic energy initial of this body, kinetic energy final of this body will be equal to kinetic energy initial of this body and kinetic energy final of this body. Final. So energy before collision is equal to energy after collision. Then the collision is elastic. Inelastic, kinetic energy initial, kinetic energy initial. Collision take place, kinetic energy final, kinetic energy final. Kinetic energy is not conserved. So this initial kinetic energy will be not equal to the final kinetic energy. This is inelastic collision. Now, the law of conservation of momentum. The law of conservation of momentum states that if no external force acts on a system, the total linear momentum will remain constant. Momentum before collision will be equal to momentum after collision. Means we have two bodies. We have two bodies. We have two bodies. One body, the initial momentum is, let's say, P1. Mass is m1, velocity is 1. The momentum of this body is P2. Mass is m2, velocity is v2. So m1 v1 is equal to m2 v2. This is the initial momentum. So total initial momentum before collision is equal to P1 plus P2 will be equal to m1 v1 plus m2 v2 into v2. This is the total initial momentum. If collision take place, velocity changes will become v1 prime and velocity will become v2 prime. Momentum will become p1 prime, p1, v2 prime, and v2 prime. Velocity changes, mass remains constant. So after collision, momentum is p1 prime, p2 prime will be equal to m1 v1 prime plus m2 v2 prime. I will write here p1 plus p2 prime is the initial momentum, final momentum after collision. m1 v1 prime plus m2 v2 prime. This is the momentum after collision. So I will write according to the law. According to the law, P1 plus P2, this is momentum before collision, will be equal to P1 prime plus P2 prime. This is after collision. So P1 is M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime. Momentum before collision is equal to momentum after collision. Now, law of conservation of momentum. Law of conservation of momentum. The total momentum before collision is equal to the total momentum after collision with no external force on the system. This example is true in this in these example. Now, we will explain. It is in documented form. You can write it. To explain the conservation of momentum, let us take the following example. Consider two balls, A and B, having masses m1 and m2. Initial velocity u1, u2, and after collision, their velocity changes. Before collision, this is the velocity after collision, and this is before. So here the momentum is P1 is equal to m1 u1. Here the momentum changes. and it becomes V1 prime. M1 V1 prime. V1 prime. Here the momentum is V2 is equal to M2 V2. M2 V2. Here it is V2 prime is equal to M2 V2, this one. Now, momentum of a ball is M1 V1. This is before collision. This is after collision. After collision, before collision. So, force is the change in momentum. Force is del P divided by T. So, final momentum minus initial momentum is equal to del P. It is equal to M1 V1 plus M2 U1. This is minus final momentum initial. This is final momentum. This is initial momentum. So F will be written this one, F1. F2 will be equal F1 prime, right? F1 prime. It will be equal to for the second particle. So according to Newton law, this force will be equal to this force. This is equal to this one, which is law of conservation. I will do this on the other side. Next page I will do it. Here I will do it. Now we have written that F is equal to del P divided by T. So F is equal to Pf minus Pi divided by T. I will write here. Pf for first particle is equal to M1 V2 and Pi is equal to M1 U1. So if by putting the values, F is equal to M1 V1 minus M1 U1 divided by T. So F is equal to 1, write F1. M1 is common, write V1 minus U1 divided by T. Similarly for the second particle. You will write, I will erase, you remember this equation. For the second particle, I will write F1 prime is equal to the mass of that particle, final velocity of that particle, which is V2 minus U2 divided by T. This is the after collision. So according to Newton's third law, action and reaction are always equal but opposite in direction. F1 prime. Write M1 V1 minus U1 divided by T is equal to M2. I will write in next. Is equal to M2 V2 minus U2 divided by T. T will be cancelled with T. T will be cancelled with T. And the rest we will write. There is a minus sign. M1 V1 minus M1 U1 is equal to minus M2 V2 plus M2 U2. Now, This is minus, so transfer it to other side, right? M1 V1 plus, when it is transferred to the other side, it will become plus M1 U1. This will be transferred to this side, will become M1 V2. This will remain on the same side, plus M1 M2 U2. This is the momentum of first particle before collision. Before collision. This is the momentum of second particle before collision. This is the momentum of first particle after collision, and this is the momentum of second particle after collision. So momentum before collision is equal to momentum after collision. So momentum of an oscillatory system always remains constant. Let's see again. First, we studied the momentum of a collision. A collision can be defined as when two bodies come close so that they affect the motion of each other. The velocity of each other is called collision. Elastic collision and inelastic collision. In elastic collision, momentum is conserved. Kinetic energy is not conserved. In elastic collision, momentum is conserved and kinetic energy is conserved. Before, this is the example, elastic collision. This is the molecular structure. In a room, when gas is enclosed in a container, the molecule strikes the boundaries. Law of conservation of momentum is applied, and it is the statement. This equation is written according to law of conservation of momentum, law of conservation of energy. The second equation, we studied elastic collision, then we studied law of conservation of momentum, and the next coming topic is projectile motion. Thank you, students.